Blockspace is not scarce. It should be a commodity item. And we believe in a model where Blockspace can be tacked on as much as needed, essentially.
How does Saga work? What problem are you solving?
Saga essentially is a chain to launch chains. We try to remove as much of the scarcity from this equation as possible. We know how much it generally costs a validator to spin up a new chain for a user. The chain requester just has to pay that amount, essentially. When you design it in this way, then you can kind of scale as much as you want because validators will keep just buying new hardware to provision the actual chain that's needed, essentially, to chip away at that difference between the difficulty of spinning up your own chain versus just deploying somewhere else. That's like ultimately our goal.
Today's episode is sponsored by the Stellar Development Foundation and Flipside Crypto. They've partnered up to bring a series of Flipside quests to the Stellar network. Quests are a fun, gamified way to explore Stellar and to dive into its growing DeFi ecosystem. By completing quests, you can earn rewards and, of course, bragging rights with your on-chain activity score. Getting started is easy. Just grab a Stellar wallet like Freighter or Hana and click the link in the description to jump into your first quest. All right, Jin, thank you so much for coming on the TEACHMEDEFI podcast.
Hello, great to meet you. Should I do like a quick intro myself or?
It would be great to hear about your background actually, because there's a lot to cover. I think you've been just in different disciplines as well. I saw Bank of America, so you've been a bit on the finance side, a bit on the blockchain development side. I think you've worked at Intel as well. So yeah, give me a bit of a rundown.
Sure. So I started my career as an engineer a while back. That's what the Intel stint was. So nothing related to blockchain. I don't think Bitcoin even existed when I graduated. I might have barely come right when I was graduating, but I studied computer architecture and did a lot of work around silicon photonics, which is going deep into this. But it's we were doing a lot of research into like how to replace electrical channels with optical channels and trying to bring that as close to the chip as possible. And so there's optical channels that happens right now from data center to data center, and it's getting closer and closer where it goes from rack to rack now. But we were trying to push it all the way down to the having on-chain silicon photonics from the core to the memory, essentially back and forth, getting it shorter, and so getting the benefits of that and doing some research around that. Joined Intel after school.
Wait,
worked there
Jin,
for a few years.
Was that a Freudian slip? You said on chain, or did you mean on chip?
On chip, yeah. Sorry, yeah. It's definitely it's funny. I've been working in this industry for too long. Yeah, on chip. So what I've noticed with engineering actually is as you go deeper and deeper into engineering, you need to go narrower and narrower. Usually, not always, but you go deep into like one very specific slice. I didn't like that, and so I wanted to kind of broaden out a little bit more. So I actually hopped out, went to business school at Chicago, University of Chicago, and then jumped out on the other end as an investment banker. So that's where you were talking about Bank of America and this company called Centerview. I was doing essentially technology M&A. So working on that for a few years. Then I got an interesting opportunity. So my brother Jay, who's at the time kind of came to me and was like, "Hey, I started this project and this startup called Cosmos and Tendermint," and he was like, "Hey, do you want to come and help run the business side essentially of that project?" And he came to me before a few times, but he's always kind of jumped from project to project. And before it was mostly just him and like maybe one other guy or just him essentially, and then he was kind of describing all this stuff around Cosmos and blockchains, and he said he had like something like 10 to 20 people in his team, and I was like, oh, this is like a much more serious operation than before. And so I thought about that, and I'm like, okay, I'm gonna go help out essentially. And so I joined Tendermint kind of early on before the Cosmos Hub was launched, and worked there for about 5 years, helping bootstrap the team, the business side of things. And then one of the things that I realized over the long run while I was at Tendermint was that Making app chains for Cosmos is actually really, really difficult. It's really hard to convince projects to do that. And so, how do we like make that a lot easier and more streamlined? And that was kind of like the origins of Saga essentially, and then spun out essentially and built Saga separately.
Oh wow, okay. I had no idea. Did you just say so your brother was one of the co-founders of Cosmos?
Yeah, yeah, he is he's Jay. He's the big guy. He came up with the idea of the first Tendermint, which is the delegate proof of stake concept. So um, before Tendermint, I don't believe there was actually a valid use case of a delegated proof of stake network, and people were trying to use this for various things, and it turns out blockchains is one of those really good applications for um, uh, uh, you know BFT algorithms essentially. And so yeah, it was. I believe the Cosmos Hub was one of the first experiments of BFT um, um, algorithms out in the world that scaled out from more than just like a couple of nodes essentially to like 100 nodes essentially in the beginning. So
Yeah, it's pretty exciting. What was that time like for you? So you've been around like for the journey of Cosmos, which must have been quite wild.
yeah, yeah, it was interesting. My so a lot of people come into blockchain through Ethereum or Bitcoin, right? The big dogs, and their sense of like how what they think about infrastructure is like very different from someone who kind of like Cosmos native essentially. And so I got introduced essentially already starting from, hey, app chains are what's going to happen essentially. That is the future. I think like every other technology in the world, it's all about timing, right? And I think app chains at the time were a little early, but it was a really interesting kind of experience going through that, at least knowing what the pain points are very early on, and trying to design a product and things around that vision is I think it's interesting. It's kind of what Ethereum is going through today, but it also I think is a little bit early as well, which is kind of funny at the same time. But I see a lot of the pain points that Ethereum ecosystem is kind of running through is pretty similar to a lot of the pain points that Cosmos kind of ran through. It's just it's a different scale, obviously, because it's a much bigger project. But it's kind of entertaining to see at least that analogy playing out essentially.
In what domain do you see those issues? Is it more on the product and strategy side, or is it on the tech side? Like, how would you frame that?
A lot of it is actually human related, actually, which is kind of funny. Um, the um, when you try to solve the issue of scaling through parallelizing through app chains, you offboard a problem from being like a kind of like a technical limitation into a human limitation, which is like how fast can humans run and operate and scale this platform. So, for example, back in the day when Ethereum was just one single chain, the operations of this was how fast can we make this chain faster, right? Once you start adopting kind of app chains and layer twos, it's the question then becomes how quickly can people spin up these layer ones and layer twos, and how fast can they connect them together essentially. And once you introduce kind of like that human aspect of it, it becomes very difficult to manage, in my opinion. And so Cosmos kind of ran into that. It's the same thing, like when you try to launch a Cosmos chain, it's like you have to go spin up, a set of validators. You need to convince validators. There's like I would say, like months of work that needs to go in to prepare for this kind of deployment, essentially. And so, and that's not ideal. Usually, what you want to do is you want to go the opposite direction. You don't want to go more towards depending on humans and waiting on humans. You want to go less and less if you want to go scalable. And so that's, I would say, is the biggest contention of horizontal scalability is introduction of that human. And really Saga, really all it is about is like, let's try to remove as much of the human as possible essentially back while keeping the architecture of app chains essentially.
All right. It sounds to me a bit like also focusing a bit more on providing the primitives that you need on the layer one, and then it's easier for app chains to spin up and perhaps just have the shared security of the layer one. I know that there's I think who was early to the shared security meta was probably Polkadot. But I think it was similar to Cosmos in that it was maybe too early. But you see that narrative now a lot, I think, with shared security. So yeah, just curious about how you think about these topics and how they find their way into Saga, your project.
Yeah. I think the complication with a lot of this conversation, at least in blockchain, in the blockchain spaces, there's this scalability, horizontalness. There's the thing that I just talked about, which is the security aspect, right? And then on top of that, there's like token economics and incentives. Like all three of those is kind of pushing and pulling the project in different ways. I would say with Polkadot, their biggest problem was on the last part, the token part, essentially. I would say that they had a really good design of how to make horizontal applications, but because of the way that this is designed it, they have a limited number of slots for projects, essentially, right? And so that now becomes um, like a limiting resource that someone has to fight over, which doesn't really solve the actual resource problem to begin with, which is kind of the problem, right? So originally Polkadot went and was like, hey, let's build out this thing where we can scale out horizontally. That's kind of the similar idea. However, if you design your token economics such that everyone is still competing for slots, you haven't really introduced a new paradigm. All you've done is you've punted the problem down to a later position, which they ran into essentially, where okay, now projects are fighting, and then it costs millions of dollars for someone to get a slot, essentially, right? And so it is very difficult, I would say, and I would say it's very similar to the way that Ethereum is today, kind of thinking about this as well. In my opinion, is they're running down the same path where uh, their ultimate model also is still a scarcity model, where the way that Ethereum as a chain accrues value is through maximizing kind of the revenue it makes from the DA, essentially, from all these L2s. But that DA is still limited in capacity, right? And so unless Ethereum starts kind of sharding these DA layers out off of Ethereum, they're going to run into the same problems where eventually the L2s are essentially going to start clogging Ethereum, and then it's all the same stuff again, right? And the problem generally with L2s that clog, usually in the past, when Ethereum was so clogged that people were upset, people just stopped using it for a little while, and then things went back to equilibrium. The problem with L2s, though, is that when L2s run into this congestion problem and they're like, we can't afford Ethereum anymore, they generally, what happens is they go to find a new DA layer, and then they don't come back to Ethereum ever, right? So the risk profile that Ethereum as a protocol is making to make the scalable choices is actually pretty risky, because they can go to Celestia, they can go to other places essentially and get that DA that they need to. And then once Ethereum gets decongested a little bit, like there's little motivation for them to come back, right? Ultimately, and so there's some really interesting economics that are playing out in my opinion in the space today.
Yeah, that's true. But what about, like, isn't Blockspace a limited resource? Like, how would you go about kind of allocating the block space to these different apps and consumers of space in the block, so to say?
Fundamentally, the origins of Saga is that our team believes that block space is not scarce. It should be a commodity item. It should be able to be scaled infinitely, essentially, and infinitely with a star. Obviously, the upper bound is like how much compute that exists in the world. But humans in general are very good at building efficient compute. That is something that we have solved essentially with the cloud model, with various data centers. I don't think that's really a limitation. And then like it comes down to like how fast can we print chips, but like that's a ridiculous number compared to how much we need right now. And so um, I don't think Blockspace is. A lot of people fundamentally think that Blockspace is limiting. I don't think so. There is a solution out there essentially, and I think that's what we are pursuing essentially. Where we believe in a model where Blockspace can be kind of tacked on as much as needed, essentially. And a lot of the limitation that exists today comes really from the fact that the projects are kind of choosing, I would say, bad token economic design. And I'm coming back to that essentially, in my opinion. So yeah, fundamentally, like the way that Saga thinks about things is like, I would say is as a team, we think about things in a very different way than most other protocols out there, because that's like our goal. We're like, how do we make this as a commodity as possible? Is like what all we think about essentially.
Right. Can you share a bit about that? Like how does Saga work? What problem are you solving?
So Saga essentially is a chain to launch chains, and that's like the easiest way to think about it. So you go to the Saga mainnet, you get a ledger or you get whatever you want, and you kind of create you put a transaction in there saying, hey, I want a chain with this configuration. In the background, essentially, the validators that we have for our mainnet spins up a new chain, connects it, and then gives it with that configuration that the user requested, essentially. And the idea is that this new chain inherits the security from the base chain itself. And the idea here is that a new project generally wants to spin up a new chain to put the logic on, essentially. So let's say I'm a project, or maybe I'm a game, or whatever we want, essentially. What I would do is I would go to the chain, request a chain that says, I want Jin chain. I want the Jin token to be the token that people use, and then the chain itself essentially spins up a new chain for you. The way that we generally think about the token economic side of things is we try to remove as much of the scarcity from this equation as possible. So what we do is we know how much incrementally it generally costs a validator to spin up a new chain for a user, essentially. So what we do is we have an economic model where the user, the chain requester just has to pay that amount, essentially, and then it gets distributed out to the validators. And when you design it in this way, essentially, then you can kind of scale as much as you want, because validators will keep just buying new hardware to provision the actual chain that's needed, essentially. And if tomorrow a 200 chains kind of come, they just need to buy 200 chains worth of compute to be able to service this ultimately.
Oh, okay, interesting. And does that chain then get allocated some fixed amount of block space on the layer 1 Saga?
No. So the way that we actually operate all of this is that each chain is essentially an independent layer 1. So there is no settlement back to the layer 1. There's no none of that, essentially. So all of the security guarantees come from kind of shared security. Every single one of our chainlets have the same number of validators as our mainnet, essentially. So whenever someone requests a new chain, all the validators doing is they're just spinning up a new node, and then they're connecting it to the same number of validators that exist outside, right? And so because of that, there's no like settlement back to the layer. We've disconnected all of that, and each chain is pretty much independent from each other. They each have its own state. It has its own finality. It has everything, essentially. So the amount of traffic that needs to come back to the mainnet is essentially pretty much zero. There's a little bit, because there needs to be some coordination between that new chain and the main chain to make sure that they're still in sync. But that's pretty minimal ultimately. So
right. So in terms of the crypto economic security, let's say the staking, is it that does the new chain need its own staking, or is it then bound, like associated with the Saga staking?
Yeah, it just uses the Saga stake, essentially. So
if a validator misbehaves on this new chain, the Saga stake would get slashed.
Yeah. We also fundamentally, it's kind of funny. We actually fundamentally believe that slashing is not really needed either. So, but it is the same security. So the way to think about this is the incentive for the validator to not misbehave in our scenario is, instead of the slashing mechanism being the primary driver, the revenue generation that this slot of validator fits is what keeps the validator in check essentially. So what ends up happening, the way to think about it is if they start doing malicious things in chainlets, that malicious activity gets relayed back to our mainnet, and they get kicked out essentially of the validator set, and they can't join back in because they're jailed essentially, and so they do not earn the revenue they would have if they had stayed in there essentially. And that's we think is the best mechanism to design this. And so users lock up their assets to show that they want to support this validator, and then the validators are earning money based on that. And then if they misbehave in any of the chainlets, it gets relayed back. And then if it's bad enough, they will get kicked out essentially. And then another person will have to spin up a validator and then attract the stake essentially.
Okay. A different type of punishment than just slashing some money away. Okay.
Yep. Yeah, because slashing, it's one of those things where a lot of the times, I mean, we can slash as well, but it's like we don't think it's really necessary. We haven't seen really in a proof of stake system the ability for a coordinator to attract enough, power to really attack the network in that way. And so slashing usually what ends up being is the validator operator just kind of mistakenly double signs essentially. That's usually what happens, and then a bunch of people get slashed. It's like, why do you even have that? Because essentially, when you have that kind of configuration, what ends up happening is it actually kind of stifles innovation, because the validators will try to do the safest thing possible. They're like, we will not do anything to our infrastructure or change anything because we know our existing product works essentially. What you do want is you want some innovation in there. You want the validators to go and try to improve just a little bit. And they'll make mistakes along the way, and they'll pay for that essentially. But it doesn't have to be such a like a strict thing as slashing, in my opinion. But
so does that mean you suspend them for a while? You don't forbid them to contribute at all anymore?
Yeah. Usually, if it's a double signing situation, at least in Cosmos, the way it happens is they get tombstones. So that wallet is no longer able to manage that validator essentially. So they'll have to spin up a new validator node and attract the stake again essentially if they want to start over, right? That's pretty much the punishment. It's like you have to now regain all of the stake that you already got before essentially. That already exists in Cosmos, and so I think slashing essentially, I don't think it's like that really necessary. It's like punishment for the users on top. There's ways of going about this where a lot of the time, if you look at Solana as well, I don't think Solana even has automatic slashing anyways, because what they do is if they figure out that the network got attacked, usually what happens is the network goes down first because consensus cannot be reached. When you spin back up the chain, what you do is you do an analysis to figure out if there was an attack, and then you remove the attacker essentially from that chain. And so there's really no reason to have an automatic slashing mechanism. It's like you can actually do 100% slash on the attacker post fact if you wanted to ultimately.
So you've been live for a while, right? So what's been the kind of use cases built leveraging Saga that you have been excited about? Like, what are you seeing there? I read a bit about Liquidity integration layer as well. So yeah, just trying to wrap my head around the ecosystem.
Yeah. So let me do a quick intro on the Liquidity integration layer, and then I'll get back to the things that we're building on top of. So okay, so we launched Saga, and we're like, okay, let's go have the users, the builders go and build out chainlets and do things. So as soon as we opened that up, well, we got a bunch of feedback essentially from our builders, and they were like, hey, actually building Liquidity for a new layer one is actually a lot harder than like we don't want to manage that essentially. So we're getting this feedback that like the big problem is that you can get the chain itself, right? But if you need to go and manually stand up a connection through Axelar or other bridges essentially to connect to Ethereum and attract liquidity, you're back to the same problem where you have to talk to a human to try to convince them to onboard you. It's like moving away from that like kind of automatic infrastructure back to other human problems. And so we were like, okay, we got that. Understood. That's a wonderful feedback. And so we kind of concocted what we call the liquidity integration layer. And what this essentially is so when a user spins up a new chainlet, it not only spins up, it sets up the validator, spins up the infrastructure, and gives them a layer one. It now connects that layer one to every other chainlet out there, and essentially to the outside world automatically. So all of the piping needed to spin up like the bridges, the routing, and the within the Saga infrastructure itself is automatically stood up and then integrated with. And so that's what liquidity integration layer is. And so it's if you think about kind of the way that we're thinking about this is there's like the ideal dream, I would say, is every application kind of has its own chain and it's interacting this like chain to chain world. But every single time someone tries to do something on that chain, there's a problem. There's like the human aspect that's making a friction for that user, for the developer essentially. So what we're doing is we're just hammering one at a time. It's like whack-a-mole, right? We're like, all right, we've solved the validator problem and the security problem. We've solved that. It's like, okay, now we have the bridging problem. It's like, okay, we're going to automate the bridging problem, and we're going to see what pops up next afterwards, essentially, and then we're going to keep popping that going forward. And so that's what liquidity integration layer is. We just went live with that, I would say, like 3 months ago, 2-3 months ago. Pretty good. It's like essentially it's all of the bridging infrastructure in the background that's stood up. You can go essentially today from Ethereum directly through Axelar up to what's called the Saga EVM chainlet, which is the chainlet that hosts a lot of our DeFi layer essentially. So we have Uniswap v3 on there. We have Oku live on there. We have like Beefy, Merkle. All that stuff is live on there. But essentially, when a new project comes and says, "Hey, I want to spin up a new chainlet," we want them to be able to access all that things that have been deployed essentially on that Saga EVM automatically. Yeah, some improvements that we're introducing, but that's really the goal. Is let's remove a BD layer, a human layer from this essentially, and automate all of that, such that when someone a college student wants to spin up a new chain to experiment with something, that's kind of what we want, is for them to just go on Saga, just put some money in, bloop, they get a chain they can rent essentially for like a month essentially, and then if they can experiment with it and then they can kill it if they wanted to, they can keep that and productionize it and make it live, quote unquote. It's kind of really up to the owner of the chainlet to kind of maintain what they want to do with it ultimately. So.
Okay, so it's like, is it like a hub where you make all the connections, the bridges to Ethereum and everything, and then this is this EVM chainlet on Saga, and then all the other Saga chainlets can hook into that chainlet?
Exactly. So we have like a whole architecture in the background that sets us all up. It's kind of like our transfer routing essentially. So the way that it works is we think of our mainnet as the best place to interface with any chains outside of the Saga ecosystem because it's the most secure, right? And so the general route it takes is any bridge from the outside connects directly to the Saga mainnet. We have a kind of a chainlet in the middle called the hub chainlet that routes everything inside of the Saga ecosystem. And then every chainlet connects to that hub chainlet essentially. So right now, if you actually go and move assets from Ethereum to Saga EVM, it goes from Ethereum to Axelar to Saga mainnet to Saga hub up to the Saga EVM chainlet. And when a user does that, we partner with Squid on this. It kind of routes that automatically, essentially.
I like them. We had them on the show.
Yeah, they're cool.
Squid is on Axelar, right?
Yeah, they're on Axelar. We're also, obviously in the long run, we can support all different kinds of bridges essentially. So the idea is like, let's say a user wants to use Wormhole from Solana back to Saga. All we have to do is then us as a project has to go and BD with Wormhole, right? And open up that connection essentially. And then every user in the Saga ecosystem can kind of utilize that path automatically. And that's the direction we want to go. It's like every project shouldn't have to go and BD all these separately. Like we as a foundation, as a project, should be doing that on behalf of our developers, and they can just kind of use that common route throughout the ecosystem, essentially.
Yeah, I think that makes sense. You just need to solve the problem once, and then everyone can benefit instead of making each chainlet then worry about this stuff again. And then they probably don't have your resources. Depending on the project to do the BD, they can't focus on the core business logic.
Yeah, but there's so many things that constantly come up because of anytime you have L1, L2, whatever, Appchain, this kind of configuration, you run into more problems. There's like, what if we want an Oracle? It's like, now I have to onboard Oracles all the time. What if I want like a multi-sig, like safe? Like, how does this work? Like, I think the amount of things that we have to hammer is essentially infinitely long. But once we figure out a good introductory set that is good enough for almost everybody, then at that point it's like it's better essentially to as easy to spin up like kind of your own chain as it is to just to go and deploy on somewhere like Ethereum or Base or something like that. And that's like ultimately our goal. Just slowly chip away at that difference between the difficulty of spinning up your own chain versus just deploying somewhere else, essentially. And as you get that closer and closer, that's kind of when you get the critical volume of projects kind of coming and building more and more, essentially. So,
right. What kind of chainlets have you seen deployed thus far? What are some examples?
We have like a really cool sets of examples. So recently we've launched Pump.Fund, like token issuance platforms, essentially. Yeah, like bonding curves. Called Mu.gg that recently has come. It's a wide gamut, and from at the end of the day, if you think about it, our infrastructure is pretty general. It doesn't have to be specifically anything. Traditionally, we've onboarded a lot of like gaming projects, and so there has been games that have slowly have launched essentially over time on Saga, and but there's no reason for it to be like gaming specific. It's just like our economic system is very favorable for like companies like who wants to build games, but there's no reason. Like, it can be DeFi, it can be anything essentially. So the projects that are coming to Saga essentially is that whole gamut. We have a really exciting one coming. Essentially, it's like an AI platform that also allows people to build tokens that are attached to like these AI bots, essentially, that they can utilize everywhere. What else is there? A lot of the DeFi stuff we're trying to help right now. So because liquidity integration just went live, we want to onboard more and more DeFi, essentially, because what ends up happening is, even though the DeFi products are not directly related to the other projects that are coming live, a lot of the other projects want these DeFi primitives to have access, essentially. And so we need to kind of get that baseline up and running, essentially. Kind of similarly to the bridge primitive and the stuff as well. They're like, okay, now that I have bridges, it's like I want like a marketplace I can go and put stuff in. And so we're hammering through essentially that as well. So at the same time, we're getting that wide breadth of like kind of different projects coming into Saga. So
how do you see the blockchain space kind of evolving in terms of, there's all these kind of separate ecosystems. There's not like real widely used interop between them yet, like Ethereum, Solana, and so on, Sui, Polkadot, whatever. And where do you guys fit in? Are you also like in terms of BD and tech forming then like sort of closeness to some of these ecosystems and interop with them? Or how do you see the space evolving, and what's your strategy then?
The Saga architecture is very, very general. So we've talked about chainlets that are these like app chains that are spun up within the Saga ecosystem. Right now, our focus is on EVM because most of the developers are EVM Solidity developers. But you can imagine, like, as long as each of these VM stacks kind of speak the same language as what the chainlets that we've set up, essentially, then you can kind of expand this out to all different kinds of languages like SVM or MoveVM, things like that. So that is, in the long run, still our goal. Is in the background, we kind of function almost like AWS, where people are, all the time on AWS, they're like, hey, I want these kinds of databases or whatever. And AWS is like, yeah, we'll also support that essentially, as long as they can be deployed onto the stack that in the background, the hardware that Amazon manages ultimately, right? And so from our perspective, these chainlets, we kind of think of them as like chain containers essentially. And all we're doing is we're building this like infrastructure in the background to be able to hot swap different kinds of chain containers into it. Once that happens, then it's like this question doesn't really become that relevant anymore, because from our perspective within Saga, it's like everything already talks to one another and can interact with one another and can support all the technologies in the front end essentially. And so I think that's probably what's likely going to happen. Is it's pretty difficult because right now every project and every bridge kind of has their own motivation. They're like, hey, we want to maximize value for us, not them. And so this like P2P game that exists kind of in blockchains is I don't think is very good and healthy and sustainable. And so from our perspective, it's like the easiest thing to do is to protocolize it, right? So it's like we're gonna own the bridges that exist within our ecosystem, and we will keep maintaining that. And once you do that, then it becomes super simple. And this is the discussion that was happening in Ethereum land as well, right? Where they were like, hey, we need a bridging protocol that is native to Ethereum, such that the layer twos can use it, and everyone has a universal way of doing things. The difference is for us, it's like we've kind of done that already, and so that makes our lives a little bit easier going forward. But we still have to interface with all the other kind of chains outside. So that's kind of the difficulty ultimately.
It's also probably useful to have the Cosmos background, right? I assume a lot of learnings from there that you're implementing now.
Yeah. The IBC is such an amazing product that not a lot of people outside of Cosmos really know about. It's permissionless bridges, which is like kind of insane to think about. And a lot of people, I'm kind of glad to see Ethereum kind of talking about this. The Ethereum kind of developer ecosystem, they were talking about like a native protocol bridging solution essentially, which at the end of the day would probably just look very similar to what IBC is. There's difficulty because there are some design decisions that like the Ethereum developers took, mostly around liveness versus safety kind of conversations that make IBC implementations more difficult, which is also the reason why they're pushing for ZK so much, right? Like ZK is kind of what's needed on their end to make similar things as what's available on the Cosmos IBC side, kind of natively already. And so that's going to be an interesting thing to see, in my opinion, going forward, how that plays out.
Yeah. What about adoption beyond kind of like the crypto space? I read you guys are kind of focused on reaching outside of the crypto echo chamber. What does that look like for you?
Yeah, I think there's not only like kind of culturally this is something that needs to happen, but like technically it's like super interesting as well. But I think it's more of a cultural conversation, because you can kind of make this crypto kind of more the playground for degens to come in and lose all their money, right? But the longer you kind of stay in that space, it's like you kind of lose a lot of the innovation that exists to begin with, essentially. And so, in my eyes, it's like a lot of folks that we talk to always say, "Hey, don't go and try to bring mainstream in, because essentially it's too hard." And it's like if hard things is not what you want to solve, then it's like why are you here in this space? Essentially, in my mind. And so our perspective a lot of the times is how can we use what we have essentially to help bridge needs outside in the real world that exists already. And so the I think this is just one example, but one really good example is the nice thing about crypto in general is that it removes a lot of middlemen from the equation. And so things that used to have barriers, if you use correctly through crypto, you can through blockchains, you can actually remove a lot of the middlemen and make things cheaper. A good example would be like a fiat off ramp, on ramp, essentially. So usually when a project wants to do a fiat on ramp, off ramp today, there's like a whole slew of things that they need to do because they have to go through KYC, they have to do all this like regulatory stuff. But with crypto these days, it's like there are already rails that has been set up that do this for you. So like a lot of the times exchanges do the KYC to onboard clients to begin with. So why not leverage that essentially that exists already and take that burden off of the developers that are just trying to figure out things. And so instead of trying to, let's say, move $10 from this user's account to the bank, instead of them dealing with all that regulatory stuff, they just issue some token that then Binance or someone else essentially does the KYC to figure out to make sure that they're complied for. And so I think that's the avenue a lot of the times that we're thinking about is like, how do we make convince people to adopt that essentially. And then once that happens, then it becomes a lot easier for kind of mainstream to come in because it's solving a problem, right? You can't just be like, hey, this technology is really cool, so you should just come use it. You have to kind of give a tangible reason why you would do that, and this is kind of the stuff that we're just kind of pushed through with having conversations with projects ultimately. So
yeah, you mentioned the fiat on ramp, off ramp. How would that be made easier? Can you explain what that concept, for example, would be?
Yeah. So like a lot of the times, let's say I'm a game developer, right? And this already exists in place in a lot of places. But let's say, for example, I'm like a poker game. That's the easiest example. Some people will have winnings, right? They want to cash out that winnings. Usually, right now today, the way it works is you have to do KYC AML for every client that wants to offboard from your client directly, right? Which a lot of the times is a lot of headaches because you then have to go and do it yourself, either onboard a provider that does this for you, right? Or figure out, you do it yourself essentially, which also is a giant pain in the ass. And so if you adopt crypto, a lot of the time is a lot of these pieces are already decentralized somewhere else essentially. So for example, exchanges already have KYC AML set up in place that does this for you. In fact, for free, right? The developers don't have to pay for that service. There is some fee that the user takes on the other end once they take that money out. But so you can now tap into this ecosystem of various products that exist out there that the products can use. And so it's obviously an analysis that they have to go through regulatory wise to make sure that they can issue like USDC, for example, to the user. They go figure out what they want to do with it, right? That's an interesting avenue that we're kind of exploring with a lot of projects right now.
Do you mean like, for example, then the exchange or wherever the user is already KYC'd, let's say it's an exchange, and that exchange would then issue a token to the wallet of that user, and that token means this wallet is KYC'd? Did I understand this correctly, or?
No. Usually, what you can do is you can remit USDC. Essentially, there's different regulatory regimes that exist for like games and crypto in a lot of these regions, essentially, right? So you can essentially emit like tokens out by complying with these crypto regimes, right? And then the user just has to go figure out how they're going to offboard. And once that offboarding process happens, they go and KYC with local exchanges that are complying with this with their local jurisdiction, essentially, right? So, and this is something that has been forced upon governments to try to figure out, essentially, right? Because back in the day, the offboarding entity and the fiat entity was kind of the same, right? Like every game had to offboard their own currency and do the KYC AML themselves. Now there's like this rail that exists that you can use that is a third party that does this for you, that exists, which is the exchanges. Or there's other services too. It doesn't have to be necessarily be an exchange. I think some other governments have different requirements that you have to do, and so you would have a service provider that does this for you. In fact, but the nice thing is now you have you can kind of tap into that automatically and onboard much faster than before. Whereas before you have to go, a billion steps before you can even think about actually implementing this. Now there's like this avenue in which you can kind of tap into that already exists. So you don't even have to issue tokens yourself. You can just acquire USDC somewhere, emit that to users, right? The users goes and figure out the KYC things with the exchanges themselves, essentially. So
Gotcha. What's next for you guys?
yeah, so as mentioned, the big thing that we're focusing on right now is bringing in that base layer of DeFi activity that exists on Saga. So from my perspective, at least, that's like what I'm focused on. We have other team members focusing on other things. But yeah, that's what it is. So it's like lending protocols, stable coins. Stable coins is a big part of a lot of this thing that I talked about before as well, because fiat on ramp, off ramp, people don't want to do that using some weird speculative token that goes up and down in value, and so people are expecting kind of these kinds of some kind of stable coin, and so that's the next steps that I'm thinking about. It's like, how do we help service the like the Web2 games that come in and expect kind of like a stable asset, essentially, that they can utilize as an off ramp for their players, essentially. And so from my perspective, then it's like we need to think about how do we design a CDP or some kind of stablecoin platform that allows us to be native kind of on Saga ultimately. So that's where, at least where my head's at.
Gotcha. So something like the game still has a native token, but when the user wants to cash out, it gets swapped for USDC, and then he receives that easily.
Yeah, and they can set up controls around this, right? So let's say if some games don't want those assets to be in the open market, then they can have their own markets. This is really the magic of crypto and blockchains in general, is that you can kind of at the same universe have one place that's highly controlled. The marketplace is completely controlled by the game developers versus other games who utilize third-party marketplaces and create an open economy, right? And they can coexist next to each other, which is something that's I think crypto really has opened up this avenue that didn't exist before. A lot of the times, most games out there, they were always all closed by default because they don't want to run into regulatory issues, right? Whereas now there's like a much clearer way of getting there by using the crypto rails ultimately for these developers. So.
Are you referencing like having certain permissionless smart contracts or whatever, and then permissioned ones as well?
Yeah.
Okay.
Like you can have, for example, a developer can spin up a new chainlet. They can make it so that certain tokens can only interact within that chainlet if they want to keep it as close as possible, or they can tap into, let's say, a third-party AMM, like we have Uniswap right now. If they want to just make a pool in Uniswap, that's a much more permissionless way of going about this. Users can bridge assets out from their chainlet into that Uniswap smart contract, and now it's out in the world, right? And so the magic ultimately of Saga is that you can support both, whatever configuration you want. Ultimately, we can figure out essentially a way to make work for the developer ultimately.
Right. Jin, thank you so much. This was super interesting. I mean, clearly you've thought about these things deeply, and it sounds to me like it's quite modular, and I think that's always a good way to go for these things. So yeah, thank you. Any last words? Where can people maybe get involved and check out Saga?
Yeah. I mean, join our Discord. Usually, a lot of the communications we do through Twitter, like every other project, and so just come check it out. I think we have a pretty vibrant community of builders and ecosystem participants, and so come hang out, have fun. I don't know. We're mostly here just to build cool things that people want to use ultimately, and so if you're just kind of a builder that want to join good vibes ecosystem, just come in and hang out.
Love it. Thank you.